Okay, so I just want to talk about dilations. Now, first of all, I just want to talk about if something is horizontally dilated by a scale factor of 1 on A. What that means is you need to sub in f of A of x into the equation. So if your f of x equation is equal to, say, 2x minus 1 to the 4, and you want to horizontally dilate by a scale factor of 1/2, then it would be f of 2x that you're subbing in, and you're putting that in for the x value. So you need to bracket it and put it in for the actual x value. So that means your new graph would be 4x minus 1 to the 4. If you wanted to shift a graph horizontally to the right, say by say 3, then, or even let's just say by A, then what you do is where the x value is, you put f of x minus A. And if you want to move it to the left, you put that in. So that would be to the left, that would be to the right. But if your actual function is like, let's say, ln of 5x minus 1, then it's the actual x value that you're replacing. So if you wanted to move it right by 2, then you put in f of x minus 2, because you want to go right. So that would be ln of 5x minus 2 minus 1. So that's ln of 5x minus 11. And if it wasn't a scale factor of 1 of A, if it was a scale factor of A, then you do that. So scale factor of A, that would be x on A. So it's kind of the opposite sign when it's horizontally dilated. So when you put in AX, x on A, f of x plus A, and f of x minus A, that one is horizontally dilated by a scale factor of 1 on A. This one is horizontally dilated by a scale factor of A. This one is moves left by A, and this one moves right by A. And you've just got to be aware that it is the actual x value you are replacing. So if your f of x function looks like 5x minus 1 to the 3, and so if you're going to do it by a scale factor of 1/2, that would be f of 2x, and you put that in place of the x value. That's the trick. So that's 10x minus 1 to the 3. So I've done a big question here. So I've got this one. We want to, first of all, in this order, horizontally dilate by a scale factor of 1/2. So that would be f of 2x, which is sine of 3 times 2x minus 4, which is sine of 6x minus 4. And then you want to move it to the left by 3. So you want to move it to the left. So that's f of x plus 3. So that's sine of 6 of x plus 3 minus 4, which is sine of 6x plus 18 minus 4, which is sine of 6x plus 14. And then vertically dilated by a scale factor of 5. So vertically would mean you just times the y value by 5. Okay, so your other vertical dilations, you can, if you're going to dilate by a scale factor of A vertically, so dilate by a scale factor of A vertically, that's going to be putting an A in front, and then you're going to dilate by a scale factor of 1 on A, put a 1 on A in front, and then you could also shift it up or down. So that would be f of x plus c, or f of x minus c. So the order of the dilation is quite important. So let's just say we have 2x minus 1, and we're going to do that to the power of 4. So we're going to vertically dilate by a scale factor of a third, then shift vertically up by 5. So that would be, first of all, we're going to do this, and then we're going to shift up by 5. But let's just say we did the same thing. Would it make any difference? So we're going to shift up by 5. Shift up by 5, and then we're going to vertically dilate by a scale factor of 1/3. Then that means that you would go y equals 2x minus 4 plus 5. And then when we vertically dilate this by a scale factor of 1/3, that means that we would go 2x minus 1 to the 4 plus 5. The whole thing has to be over 1/3, like the whole function. So that means the 5 that's been shifted is also dilated.